Okay, parallel circuits. First of all, you need to know how to calculate the currents going through each component, because in a parallel circuit, each component, if you are dealing with RC circuit, it means the resistor is in parallel with the capacitor. If you're dealing with RL circuit, it means the resistor is in parallel with an inductor. If you're dealing with RLC circuit, it means the resistor is in parallel with an inductor, is in parallel with a capacitor. That is 3 components. So how do you calculate the current flowing through each component? If it's a current flowing through the resistor, you're gonna do IR is equal Ohm's law. They say apply Ohm's law. V over R. If you are dealing with the current flowing through the capacitor, what do? V over X. This is Ohm's law. Remember X, Ohm's law. The value of the resistance of the capacitor, not the value of the capacitance, but the value of the resistance of the capacitor. So V over XC. And if you are dealing with the inductor, the current flowing through the inductor, so you're gonna do V over XL, the resistance of the inductor. That's how you calculate. Now, how do you calculate the total current? This was because first of all, you must be able to collect the current flowing through each branch. Then you are able to calculate the total current. Now, how do you calculate the total current? If it's here they say apply the Pythagoras triangle formula. Apply the Pythagoras triangle formula. So if it's a RC circuit, if you're dealing with the RC circuit, you know that the components are resistor and capacitor. So your total current in parallel for an RC circuit is going to be equal to square root of IR. Let me create space. I feel like I'm going to run out of space. So I total for RC circuit is going to be equal to square root of IR. So which means we're doing the current of the resistor plus the current of the capacitor, because we are dealing with the RC circuit. When we are dealing with the IL circuits, I total is equal to square root of IR squared plus IL squared. That is when you are dealing with the RL circuits. Now, when you are dealing with the RLC circuits, all of them combined, what do? First of all, after your calculation of each current, you were able to determine which current was bigger than the other between the current of the capacitor and the current of the inductor. Now, you apply it here when you are calculating the total current for the 3 of them. So you go IR squared plus, now let's go with the same logic. Let's assume IC was bigger than IL. So then you're going to do IC minus IL, the 2 of them squared, and they're under the square root. So that's how you calculate the total current. Now, how do you do with the impedance? Impedance is so simple. In parallel, the only way to calculate impedance is to apply Ohm's law. So your Z is going to be equal to V over total currents. Now, before we continue, let's observe. How do you calculate the impedance in series? You apply the Pythagoras formula. How do you calculate the impedance in parallel? Simple Ohm's law, V over total current. Now, how do you calculate the current in series? Simple Ohm's law, V over impedance. Now, how do you calculate the total current in parallel? You apply the Pythagoras formula. You can see that the series and parallel, they are opposing each other when it comes to calculating the current and the impedance. So the phase angle for an RC circuit. So what do? You do your 10 to the power negative 1 now of I. If you're doing with RC circuit, you're gonna do IC over IR. That's what you do. Now, how do you calculate the phase angle when you are dealing with RL circuits? You do 10 to the power tangent to the power minus 1 multiplied by IL over IR. Now, how do you calculate the angle when you are dealing with RLC, all the three combined? So, tangent to the power negative 1 multiplied by. Now, here, you have to be mindful to notice between the two currents again, which current was bigger? Was it IC or IL? So, if it's, let's assume again it was IC which was bigger than IL, then you do IC minus IL over IR. So that's it. So picking a formula is a very important thing to do, knowing first of all the components which are in the problem that's given to you. Second of all, you should know how those components are connected. Then you're going to know what formula to take. Thank you.